Hello everyone, it's Mr. Spinelli. I'm going to go through some basics of how to multiply polynomials. So, in our first three problems that we're going to look at, I'm just going to distribute something to an expression. So in this first one, I am distributing a simple constant, -8. And I have to distribute it to all three of these terms inside of the parentheses. So what I'm going to do is multiply the -8 by each of the coefficients. In this case, the 2, the 3, and the 1. So -8 times 2 gives me -16. The y squared remains exactly the same. -8 times a positive 3 gives me -24. And the y stays the same. Now the last term doesn't have any y's, so I just do -8 times 1 to get -8. Okay, so again, all I'm doing is multiplying coefficients by each other, and later I'll apply some rules of exponents. So in the next one, I'm distributing a positive 3x squared to each of the three terms. So I'm mostly going to focus on multiplying the 3 times the 5, -8, and positive 1, and then I'm going to multiply the x squared times the x cubed, the x, and then this term doesn't have any x's, so I could think of it as x to the 0. So 3 times 5 gives me 15. When I multiply x squared times x cubed, I add the exponents. So 2 plus 3 gives me 5. So I've got 15x to the 5th. When I do that to the second term inside the parentheses, 3 times -8 gives me -24 as a coefficient. And I'm going to do x squared times x. Well, x is really x to the first, so I add those exponents. 2 plus 1 gives me 3, so I've got x cubed. And then lastly, when I multiply something by 1, well, I just get the same thing. So I'm going to have plus 3x squared. And so this would be my final answer. So key things to remember are that when you multiply things with the same base, so for example, x to the a times x to the b, freezing up here, I need to add the exponents. So this would be x to the a plus b. So let's take a look at another example, and I invite you to pause this before I go over it. So I'm going to distribute -2x cubed to each of these terms. When I distribute it to the first one, -2 times 5 gives me -10. And then adding the exponents, 3 and 4, gives me x to the 7th. Now when I distribute to the next one, -2 times a positive 3 gives me -6. 3 plus 3 for the exponents gives me x to the 6th. Then when I distribute to the third term, -2 times a -1 gives me +2. Add the exponents 3 and 2 to get x to the 5th. And then lastly, when I multiply by a 7, I'm going to get -14 x cubed because there were no other x's to begin with. And then this would be my final answer. Okay, so now all of these, I was distributing a single term polynomial or monomial to some kind of polynomial. So then when things get a little more interesting, I have polynomials with more than one term being multiplied by one another. In this case, I have a binomial times a binomial, two polynomials with two terms each. So what I have to do is the x from the first term needs to be distributed to both things. So I'm going to do that first. So I'm going to do x times 8x minus 1. And then I need to distribute the positive 5 to each of these two terms. So I'm going to do plus 5 times 8x minus 1. Notice the plus had to go with the 5. So now when I simplify this, I distribute the x to each of these terms, the 8x and the minus 1. I get 8x squared minus x. And then over here, I get a positive 5 being distributed. So I get plus 5 times 8 is 40, and the x comes along. 5 times a -1 gives me -5. And the final result, I have to combine these two terms in the middle because they are like terms. So I end up with 8x squared plus 39x minus 5. Now there's several ways to do this problem. Some people like to make a table, and you can do this for multiplying any numbers you want. So I'm going to make a 2 by 2 table, and on the outside I'm going to write each part of the polynomial. So from the first one I had x and a positive 5. For the other one I had 8x and a negative 1 because it was minus 1. So what I'm going to do is I'm going to multiply the x and the 8x together and put that in the box where they cross over. So I get 8x squared. Remember, these are really x to the first. So I add the exponents and I get 2. So x times x is x squared. Now I multiply the 8x times the 5. I get 40x. I multiply the negative 1 times the x and I get negative x. Negative 1 times the 5 gives me negative 5. And now I simply have to add together all of these terms. Add them all together. Now you will notice that there's usually a diagonal pattern. So there's only an 8x squared. There's no other x squared terms. There's these two terms which are linear. So 40x minus x gives me plus 39x. And then I just have this lone negative 5. Okay, and I get the same result. So again, I had to distribute the x to both the 8x and the minus 1, and I had to distribute the positive 5 to each of those. And I can get that by doing it by hand on the left or using a table on the right. Now here's another example. So again, I'm going to distribute the 2y to each of these terms. 2y times 5y, 2 times 5 is 10. Y times y is y squared. 2y times a negative 8, 2 times the negative 8 is negative 16, and I still have a y. And now I'm going to distribute the positive 3 to each of these terms. 3 times 5 is 15, so I get plus 15, and along comes the y. 3 times negative 8 gives me negative 24, and I wrote it in this particular way for a reason, because now if I add straight down, there's no other y squared terms, so I get 10y squared. Negative 16 plus 15 is negative 1, so I get negative y. I can put the 1 in front of the y if I want, but it's optional. And I get minus 24. So again, I invite you to pause the video before I tackle these problems so you can check your own work. So here's another one. Here's a challenge I invite you to try before I attempt it, but I have to distribute a binomial to a trinomial. So if I start with the x, distribute to each of these three terms, essentially all I'm going to do is add 1 to the exponent. So the 2x cubed becomes 2x to the 4th, the x squared becomes x cubed, and the 4 just gains an x squared. And of course it was a minus 4, so it's a minus 4x squared. Now I'm going to distribute the negative 3 to each of these terms, and I'm going to get minus 3 times a 2 gives me negative 6x cubed, and then I've got minus 3x squared, and plus 12, because negative 3 times negative 4 is positive 12. Now, if I add these things straight down, because I've lined up things in terms of their degree, so I can combine like terms, I get 2x to the 4th minus 5x cubed minus 7x squared plus 12. Okay, so continuing on, here's another example, but now I've got two trinomials. So this is where it gets a little messy if you're not careful. I'm going to first distribute the 2x squared. 2 times 3 gives me 6. Add the exponents, 2 and 2 gives me 4. Minus, because I've got this minus here on the 4x. 2 times a negative 4 gives me minus 8. Add the exponents, x cubed. Next term gives me plus 14x squared. And then I'm going to move on. Now I'm going to distribute the positive 5x. Positive 5 times 3 gives me plus 15. And then I've got an x cubed. Positive 5 times negative 4 gives me negative 20. And then I've got x squared. And positive 5 times 7 gives me positive 35x. And last but not least, I'm going to distribute a negative 1. Well, that's easy to distribute because I just changed the sign of everything in the second expression. So I go negative 3x squared, positive 4x, and negative 7. And then I get to add straight down because all of my like terms are arranged by degree. So I get 6x to the 4th plus 7x cubed minus 9x squared So that's 14x squared minus 20x squared minus 3x squared. Then I've got plus 39x and minus 7. So that time I had to triple distribute from that first trinomial to the second trinomial. Now I've got another binomial, but now I've got x's and y's coming into play. So I'm doing all the same work though. When I distribute my 2x, 2 times 4 gives me 8. Then x times x, I'm just going to actually write it like that, x times x. And I'll simplify this later. Now when I distribute this way, 2 times, there's no coefficient in front of the y, so it's a 1. I get 2xy. Now moving on to the negative 3y, negative 3 and 4 multiply to give me negative 12. And then I get y times x. Negative 3, y times y. And now let's clean everything up. Well, we said that x times x, I just need to add these exponents. So I get 8x squared. Well, I can't combine x and y because they're different variables. So I get plus 2xy. Then minus 12yx. Well, the beauty of multiplication is that it's commutative. I can do it in any order I want. So I can actually flip the direction of the x and the y on that third term, and then I'll be able to combine these two terms. So I'll end up with 8x squared minus 10xy, and then of course the 3y becomes simply 3y squared, so I've got minus 3y squared. Last but not least, here's a problem applied to a little bit of geometry. First, it's asking me to find the perimeter. So in order to find the perimeter, I have to add all 4 sides together. Now, I've only got 2 of the sides labeled, but the beauty of a rectangle is that this one would also be 3x plus 5, and this side would also be 2x minus 1. So one thing I could do is I can exploit the properties that these are the same. And I'm actually just going to add these two together and double my result. Okay, so 3x and 2x give me 5x. Positive 5 and a negative 1 give me plus 4. I'm going to double that result, so multiply it by 2. That's probably not the most appropriate way to say that. I'm going to double to get 10x plus 8. So again, I could have added every single thing up. I could have done 3x plus 2x plus 3x plus 2x to get 10x. And then I could have similarly done 5 plus 5 is 10, minus 1 is 8. Okay, so I'm adding up all 4 sides. Now in order to find the area of a rectangle, I have to remember the formula. It's base times height. In this case, my length or my base is 3x plus 5, and my height is 2x minus 1. So now I need to perform my double distribution. So the first thing I'm going to do, multiply the 3x by the 2x to get 6x squared. 3x times the negative 1 gives me negative 3x. And then I'm going to go through and distribute my positive 5 to the 2x to get positive 10x. Positive 5 times negative 1 gives me negative 5. And last but not least, I need to add in order to combine like terms. So I've got 6x squared, negative 3x plus 10x gives me plus 7x, and minus 5. So this would represent the area of this rectangle. Hope you enjoyed. Good luck in your studies.